Hello, I am Ayush Srivastav, roll number 20010865 from Triple E branch. This is video assignment for lecture 10, which is Bernoulli and binomial random variables. So let's start with the question. The question is as follows. Students of college Y have got frustrated due to ongoing online semesters and are obsessed to return to campus, but the authorities are ignorant about all these. So the patience limit of the student has crossed and they decided to mail the authorities every third day. They decided to request for permission to return, and there are three factors which govern the return of the students. That is, CNET body agreed to call back the students, SOP of the government should be in favor, and there is also a rumor spreading about the onset of new wave, which should be the discarded by the authority. Then only they will call back to the students to the campus. The probabilities of all these are zero point 0.8, zero point 0.5 and zero point 0.2 respectively. So we are assuming that the authority replies to every mail which the students make to the authority, and we need at least three mails in affirmation because we have three batches of students. So if one mail will come, batch 1 will go, second mail will come, batch 2 will go, and third mail will come, then batch 3 will be going to the campus. So we need at least three mails. So we have to calculate the probability that all the three batches will be lucky enough to enjoy their campus life after 28 days. So let's start with the solution. We are choosing x to be a random variable which denotes the number of mail replied by authority in affirmation. That is, the authority says yes, you can come back to the campus. So as we need at least three mails in affirmation, so our random variable should be greater than 2, then it must be at least equal to 3. So we have either the authority saying yes, you can come back or no, you can't come. So we can treat it as a Bernoulli trial with success as positive reply and failure as the negative reply. So we could use the Bernoulli trial formula for calculating probability of x equals to I. Here we let n to be the number of trials performed and p be the probability of success. So by Bernoulli trial formula we have probability of x equals to I as nci p to the power I 1 minus p to the power n minus I. This can be easily proved as we have to get I successes and probability of each success is p. So we have to multiply pi times and rest of the n minus I should be failure. So 1 minus p multiplied n minus I times, and these I could be anything from n, so we could use n choose I. So we need n and p to proceed with this formula. First we calculate n. As the mail is sent every third day, for example first day, fourth day and so on, we could calculate it by 28 minus 1 by 3 as the last mail is sent on the 20th day and the first mail is sent on the first day. 28 minus 1 by 3 plus 1. So we have n equals to 10. For calculating p, we need three events to be in favor. That is, college discards the rumor, SOP of government supports the return, and CNET body agrees for student return. They should be zero point 0.8, zero point 0.5 and zero point 0.2, and they are independent events, so we can calculate probability as p equals to p1 times p2 times p3, and we will get probability of mail coming at success as 0.08. So we substitute the values of n and p in the Bernoulli trial formula and get 10 Ci, 0.08 to the power I, zero point 0.9 to 2 to the power 10 minus I. And here I could be anything from 0 to 10, as either 0 mail will come as success or 1 mail or 2 mail or so on till 10 mails. As we need at least 3 mails in favor, so we have to calculate P as P of x equals to 3 plus 4 so on to 10, and we know that either 0 or 1 or 2 or so on to 10 will be the mails coming in favor, so adding this will result in 1. So we can calculate P as 1 minus P of x equals to 0 plus x equals to 1 plus x equals to 2. After putting the values of 0, 1 and 2 in the formula calculated here of P of x equals to I and simplifying, we get P as 1 minus 0.08 raised to power 8 multiplied by 36 times of 0.08 whole square plus 8 times of 0.08 plus 1. Simplifying, we get P as 0.04007, which is nothing but probability as 4.0075%. Thus, we can say that there is an approximate probability of 4% that all the three batches will reach campus in the next 28 days. So here we are done with the question. Thank you.